So let's pick up from where we left. What we have is this expression here for the expected present value of our payment stream. And we want to manipulate it into something that looks like this. So in the end, we want to end up with something that is of the form expected value at present of a k-year pure endowment multiplied by the expected present value of an n-year annuity, life annuity due for an x plus k-year-old. Now, as we established earlier, we actually know the expected present values in both cases are these two. So we can actually just plug these values in down here. So what I had, just by copying what I have above, is kpx multiplied by e to the minus delta x multiplied by the sum for t going from 0 to, what was it again? T going from 0 to n minus 1. And then we have e to the minus delta t and tpx plus k. So we want to go from this thing up here and arrive at this thing down here. One of the ways we can do this is by calculating backwards. So we can try to find some expression that reminds of this thing up here by calculating backwards from this. So what we can see is this expression above has a summation and then stuff inside. So it's probably a good idea to multiply these two into the sum. So I can start with the e to the minus delta. Is this supposed to be a k? This is supposed to be a k, sorry. So this is supposed to be a k. So I can start with e to the minus delta k, which I multiply onto e to the minus delta t, which in total gives me e to the minus delta t plus k. And then I have, what do I have? I have kpx multiplied by tpx plus k. So I want this expression to remind of this expression up here. Now the first thing I can think about is that up here I only have one conditional survival function, whereas down here I have two conditional survival functions. So maybe we can try and see if we can change this into something more likable. So I have kpx tpx plus k. So what should I do about this? Well, I don't really know the rules for calculation of these things, but something that I do know is the definition of each of these. So the definition of the first is the probability that a newborn survives age x plus k given the newborn survives time k. And the second one here is the probability that the newborn survives time x plus k plus t, given the newborn survives time x plus k, right? And let's try to write down the definitions of these two. They are essentially the probability that a newborn survives past time x plus k and survives past time k. So the strictest criteria is this, so here we go. And then we divide by the probability that t is greater than k, since this is what we condition on. And then in the next one, what we have is the probability that t exceeds x plus k plus t intersected with the event that t is greater than x plus k, but again, we just have the strictest inequality, which is this, so we're good to go. And then we divide by the probability of the event we condition on, which is t greater than x plus k. So this goes out and this goes out. And what we're left with is the probability that t is greater than x plus k plus t divided by the probability that t is greater than k. And this is again just the conditional survival probability for a k-year-old, the next x plus, what happened? Sorry, for some reason I don't know the difference between my k's and x's, so this is just yet another reason why you should do the calculations on your own and not trust me. So I divided, so what I have is, given that t is greater than x, and here I will then divide by the probability that t is greater than x, and here I have the probability that t is greater than x. So this is the probability of an x-year-old surviving past the next k plus t years. So that went really well, just apart from the fact that I don't know the difference between x's and k's. But what we did conclude is the probability of an x-year-old surviving k years multiplied by the probability of an x plus k-year-old surviving the next t years is actually just the same probability as an x-year-old surviving the next t plus k years. And that's actually a really nice construct. So just in a box here, we can actually write, if you want to consider the probability of an x-year-old surviving the next t plus k years, you can actually split it up and say, well, what's the probability of the x-year-old surviving the next k years? And then at that point, what will the probability of the x plus k-year-old surviving the next t years be? So what we arrived at now is that we have a new expression for this product. And this new expression is given as, let's see, well, I have that this new expression is given as k plus t px, right? And what we see now is this expression reminds an awful lot of this, and the only thing that is really missing is that we switch up the indices. So we want this sum to start in t equals 0, right? So it starts in e to the minus delta k, kpx, and then it goes up to e to the minus delta n minus 1 plus k, and then n minus 1 plus kpx. So essentially what we can do is we can take the k and move it into the index. So what we have is we just sum from k to k plus n minus 1 instead, and we have e to the minus delta t, t, p, x. And lo and behold, that was also the expression that we had from above. So now we have shown that the expected present value in this case, where our contract is a deferred temporary life annuity due, is given as the expression that we wanted to show earlier.